Here is a game of chance that you virtually cannot lose. So how this works is you begin with a shuffled deck of cards. You can have the spectator mix the cards as much as they would like. In fact, they can do all of the dealing here. They can perform all of this, and you just sit back and watch and win. So how this works is you tell the spectator that you are generously going to give them the ace through the 10. So 10 values there. And you'll just keep 3 for yourself, the jack, queen, and king. So how this will work is after the deck has been randomized, 4 cards will be pushed off. If this set of 4 cards has any one of the face cards, then that's a winning hand for you as the performer. If it doesn't have a face card, then it's a winning hand for the spectator. So let's see how we did. Oh, we lost as the performer. There's no face cards. So the spectator's feeling pretty good about things right now. Okay, next set of 4. Let's see how we did. Oh, we win that one. There's a couple of face cards there, so there we go. Next set of 4, how did we do? Oh, we lost again. Oh boy, we're not doing very well, are we? Ooh. Okay. Oh, we won that one. There's a couple of face cards. We only need 1 face card in the set of 4 for it to be a winning hand for us. Oh, we win that one. There's a jack. How did we? Oh, we won another one. Okay, and how did we do here? Oh, we won another one. I'll just stack them down here. Okay, how did we do in this set of 4? Oh, we lost. That goes to the spectator. Okay, there's another set of 4. Oh, we lost again. Spectator is going to catch up here. We better speed up here. Oh, we win. There's a queen. That's a winning hand for us. Oh, we lost again. Darn. Oh, we won. There's at least 1 face card. There's actually 2. Oh, and there's a couple of face cards. Oh, darn it, for the spectator. They won 1, 2, 3, 4, 5, and we won 8 of them. So we win that round. Okay, so let's try that again. So let's go ahead and we'll mark that as a win for us. Okay, so we won that round. So very good. Okay, and then the cards would need to be sufficiently randomized again. The spectator can do all of that. Okay, so I need to assure you there's no shenanigans as far as control. There's no controlling of cards here at all. Okay, so maybe one more for good measure. Well, we'll do another one. Very good. Okay, let's push off 4 and see how we did. So if there is a face card in here, then we win that hand. Oh, there is. There's a king. Okay, so we won the first one. How did we do the second time around? Oh, we won that one too. Spectators feeling a bit nervous here. Oh, they won 1. Okay, no face card there. Oh wow, 3 8s. That's very nice. They won that one. There's no face cards. Oh, there's a face card. There's a king. That's our winning hand there. Okay. Okay, so we win this one. There's at least 1 face card. There's 2 of them. Oh, we lost. We lost. Oh, we won that one. Let's go over here. And we won that one. How did we do here? Oh, whoa, we got 3 face cards there. And we got another face card. And another face card. And that's for the spectator. So this time they got 4 and we got 9. So that's another win for us. We're playing the best out of 5. spectator better catch up here quickly. So let's gather these. Okay, randomize the deck. You can even do a table wash if you would like to really mix things. In fact, I kind of recommend that maybe you do that with the spectator. Just have them, they need to know that the cards are truly random. That you have, as a performer, you have no knowledge of anything regarding the cards, order, or placement, or anything. Okay, so that's really important. And it's not to your disadvantage in the least for this to be randomized, because you have mathematics on your side. Okay, let's go. So we're playing the best out of 5. Okay, so there we go. That's another set of 4. Oh, sorry, that's ours. Oh, there's a queen. That's our winning hand. Oh, we lost that one. Spectator got at least 1. Oh, they got 2. Oh, we're tied. I think this is the first time we've ever been tied, actually. Oh, this is the first time. The spectator has been ahead. It truly is. Oh, and they're pulling way ahead. I think we're in trouble this time. What do you think? Oh, I think we may be. That's a lot of face cards being used up in that little packet of 4. Okay, that's a win for us. I predict this one's going to be pretty close. Okay, there was a jack, so we win that one. Oh, another jack. Okay, so spectator wins that one. Very good. We win this one. Maybe it won't be as close as I thought. Not even close. And so it's 5-8 again. Okay. Well, we have won 3 out of 5, but why don't we keep going? Can the spectator win this? At least 1 round. Okay, before we go on and play a few additional rounds of this game, let me explain the chart on the left. Because if you understand how to read this, you can use it to create your own fun games of chance to play with family and friends. Okay? So what's being used here mathematically is something called the at least once rule. Now this is an idea that's taught at the high school level. Okay, so this is not an advanced college concept in mathematics. Okay, the letter R here represents the number of cards dealt at a time. So if you can see, I've highlighted 4, and it's because we've been dealing out little hands of 4 cards each, right? We've pushed off like the top 4 cards, and then we focused on just, what's happening with these 4 cards. And then over here on the left, this column, it says V, it represents distinct card values. And then I've highlighted 3 down here. Now the reason I've done that is because as the performer, I've assigned myself just 3 out of the 13 possible card values. So the card values that are, quote, mine are Jack, Queen, and King. Whereas the spectator gets Ace, 2, 3, all the way through 10. So they get 10 and I get 3. Well, this is where most spectators will make a conceptual jump that's not justified. They'll look at the number of values assigned to them, go, wow, I get 10 of them. And the performer only gets 3. Wow. I have a much greater chance of winning or having this go my way. Okay, and in their mind they might even be taking like 3 divided by this number to get like the probability that I would win, or 3 divided by 13, which is the total, and think that that probability tells us something that relates to what we're doing here, but it doesn't. Okay, so that actually would be a mistake in logic. That would mislead them. That would have them believe that as a performer with only 3 values, I don't have a very good chance of winning this game. Now, it ends up that I have a very good chance, as we'll see. Okay, so let's begin with, now what's the probability that if we were to just randomly deal out 4 cards, as we've done here, what's the probability that among these 4 cards, there's at least 1 face card? Okay, so that's what the 66% is referring to. This is the probability that there'll be a face card among these 4 cards. Now we can kind of peek at it and see how we did. There's a couple of face cards, so yes, there is, so I would win that hand. I had a 66% chance of that happening for this set of 4 cards. Okay. Now, as we deal out all hands of 4 cards, there's 13 possible hands of 4 cards, because 13 times 4 is 52, which is the size of a standard deck of cards. I have almost a 90% chance of winning each round. And each round means we deal out all sets of 4 cards, and I keep the ones that I, quote, win by having a face card among those 4. And the spectator wins all of the other ones. Okay, so they get the ones that I lose, essentially. Okay. But the chance that by the end of dealing out all 13 hands of 4 cards, the probability that I will get a majority of the hands, which would be what, 7 out of 13, right? 7 or more out of 13. The probability of doing that is almost 90%. Okay, so we can kind of see why I won the first round, I won the second round, I won the third round. So for each of these, there's about an 89% chance that I would win each of those. Okay. Now, if we play the best out of 5, which is what we've done, we planned on doing here, it ends up that the probability that I will win the best out of 5 is approximately 99%. It's almost guaranteed that if you play this little game 5 times, that the performer with these assigned values will win the best out of 5. Will win 3 or more of those rounds. It's almost guaranteed. Okay, so you could just about bet, your life savings on this. I mean, don't do that. Bad idea. For lots of reasons. But so you have almost 100%, it's almost a certainty that you're going to win the best out of 5. Isn't that amazing? Okay, even though just because of the relative sizes of these little sets here, most spectators will think, man, I as the spectator have a much better chance of winning at this game, and they don't. They almost have no chance of winning the best out of 5, as we've seen right here, of course. Okay, so that's how this chart is read.